Hello everyone, I'm welcoming you all to our second lecture of Basic Electronics module. After seeing the introduction to Basic Electronics, we are going ahead with our second lecture, which is Component Identification. So basically this lecture will provide you with the basic information, knowledge and picture representation of different kinds of components which we are going to use throughout this basic electronics module. So in this particular session, you'll identify these components. So this session is divided in four topics, which are introduction to electrical components, in which you'll see the different types of electrical components and briefing about them. Then after we will see the different types of general purpose components. Then after we will see active and passive components, their types and different categories of them. And in the last slide, we will see circuit and schematic diagram of these components and how we make a circuit. So we are starting this very lecture from the types of electric components. So electrical components are mainly divided in four types, which are passive components, active components, general purpose components, and electromechanical components. So the first component, which is passive components. So which are the passive components? So the very basic definition of passive components are the components who doesn't require external and individual power source to run. Means they operate without any external power source or individual power source. They are called as passive components. For example, resistor, capacitors or inductors. In further lectures, we'll see the circuit, then you will notice that these components, resistor, capacitors and inductors, whenever they are in circuit, they don't require their personal power source to run. That's why they are called as a passive components. While active components are those who requires and who must have their personal external power source to run, without which they cannot be operated. So the active components need an external power source to run. For example, your diodes, transistors, MOSFETs, LEDs. These are some of the examples of active components. Then after there is the third type, which is general purpose components. So these are nothing but the helping tools. Means in this general purpose category, the tools which are used in building a circuit or assembling a circuit or assembling two components or joining two components, means whichever tools we are using to build a circuit or join a component or deassemble a circuit, the every components are goes into this category, general purpose category. For example, wire cutters, soldering irons, jumper wires and breadboards. These are general purpose components. Then after the last and final type is electromechanical components. So as the name suggests, it has two individual words. Electromechanical is electrical and mechanical. So these are the devices which are operated manually by some physical or moving parts and they carry out an electrical operation. So that's why they are called as electromechanical components. So some of their examples are relay and switches. Switches means we are using in our day-to-day life to turn on and turn off our home appliances. So we are turning them on and off by moving parts or by switching with our hands, and they perform some electrical operation by switching an electrical component, turning it on or off according to our purpose or our explanation. So they were electromechanical components. So these were the basic four types of our electrical components. Now moving forward with the general purpose tools. So in this particular subtopic, we will see the different kind of general purpose tools which we use in our circuits and component sections. So what are general purpose tools? So the general purpose tools used as helping hand for cutting or welding or to joining the different parts. In making the electric circuits are falls under this category. Means these are you can call as helping hand tools which helps you to build a circuit for cutting purpose or welding purpose or join different parts. In this, the very first is breadboard. So let's see what is breadboard. So breadboard is an essential tool for prototyping and building temporary circuits. Means breadboard is something you use while prototyping your circuit. Means you are not very sure but you just want to experiment or to check whether your circuit is performing as the as your aim or as your purpose. So for that purpose you connect your different parts on this breadboard. Otherwise you'll have to solder it, but when once you solder the components you cannot easily detach them. But breadboard is something you can attach attach a component and then detach whenever you want. So this is specifically for prototyping and experimental purpose. So these breadboards contains holes for inserting wires and components. Because of their primary nature, they allow you to create circuit without soldering. The holes in breadboard are connected in rows both horizontally and vertically as shown below. So as you can see in image, the middle two columns or you can say the middle two blocks are once they are this in them these pins are connected vertically. Means there is a vertical copper path copper wire which are connecting the A B C D and E parts together, only A to E. Then there is another copper wire which are joining F, G, H, I and J in series. So in the two modules in the middle section of breadboard, they are connected vertically. But as you can see in the uppermost part and the lowermost part, there is a sign of positive and minus, positive and negative, both the side, upper and lower. These pins are connected horizontally, means from very first plus to the very next right side of plus. They are each and every hole from left side to right side, positive left to positive right. They are connected horizontally with a conducting wire. Similarly for negative, from first hole of negative to the very last end right side of the negative, they are connected in series. So this is the breadboard which we use for prototyping and experimental purpose. Then these are jumper wires. A jumper wire is an electric wire that connects remote electric circuit used for printed circuit boards. So jumper wires are nothing but used to connect different two parts together. In jumper wires, there are different three types, which are female to male to male, and female to female. Means in male to male, there are pins coming out of the wire, and in female portion there are no output pins, there are only holes. So there are three different parts of jumper wires, and jumper wires are used to connect the different components with each other. And also the jumper wire provides that conducting path which we discussed in previous lecture. So these are nothing but a provide conducting path and joining the two components together. Then the another general purpose component is digital multimeter, which has numerous uses and numerous advantages also. So as the name suggests, it is digital because it is displaying a digital quantity onto it. Means it has numbers, fixed numbers, so it gives digital output. That's why the name is digital. Then multimeter. Multi means you can perform a number of tasks on it, not just once but number of. That's why the name says multimeter. Using it, you can measure different parameters. For example, you can measure voltages, you can measure resistance of a resistor, or you can measure current, or you can check your LEDs, you can check your transistors. So many kind of so many different type of meter measuring you can perform with this single unit. That's why it is known as digital multimeter. So a multimeter is a device that is used to measure electric current in ampere, voltage in volts, resistance in ohms. It's a great for troubleshooting circuits and is capable of measuring both AC and DC voltages. As you can see, from A for AC voltage, it is a straight line, and for DC, it is a sine wave. So you can measure both AC and DC voltages. Now, this is a battery holder. So battery holder is nothing but a stand which is used to hold your cells. A battery holder is a plastic case that holds batteries from 9 volts to AA. Some holders are enclosed and may have on and off switch built in. Means this particular battery holder shown in image doesn't have any on off switch, but it is a plastic case in which you can put your cells. And the two wires coming out of this case are providing positive and negative, or you can say if your cells are of 9 voltage, then the red wire will provide you with 9 volts and the black wire is used to ground. So this is the main thing you'll have to keep in mind, is there are two wires coming out of this battery holder. One has positive voltage provider, and the another is used to ground. The black wire will always go to ground, and positive wire will always go to the positive, which will provide you with positive volts. Then there are testing leads. So these test leads are great for connecting components together to test a circuit. Whenever you need to test a circuit, then just join two components using this testing leads without need of soldering. Means these are the pins which can be used to connect two remote parts together without soldering them, and they are also called alligator connectors. So the other name for testing leads are alligator connectors, which does nothing but connect two different parts together. Then after, there is a wire cutter, or you can say wire striper. Wire cutters are essential for striping the strands and solid copper wires. So the jumper wires we have seen previous. So to cut any wires, or to cut the rubber case of that copper wire, you will need this wire striper just to cut or stripe your wire. Then after, precision screwdriver set. They are also known as jeweler's screwdrivers and usually comes as a set. So these are the screwdrivers which has the number of different leads. According to your purpose of screwdriver, you can use any of them. So these are the screwdrivers which are used to fit the bolt or loose the bolt. The advantage of these over normal screwdriver is the precision tips of each driver. These are very handy when working with electronic that contains tiny screws. To fit the tiny screws or to lose any tiny screw, you will need precision screwdriver. Now, helping hand. Helping hand is nothing but an extended part of soldering. While you are soldering, you have so many components to solder together. So this helping hand is provide you the third hand while you are working. So when working with electronics, it seems you never have enough hands to hold everything together. This is where the helping hand, means you can say as a third hand, comes in. Great for holding circuit boards or wires when soldering or timing. Means you have to have connect more than three parts, then you can connect two of them on this helping hand and you can solder easily. Now heat gun. A heat gun is used to shrink plastic tubing known as heat shrink to help protect exposed wires. Means to shrink any wire, you can use a heat gun. Heat gun shrinks your plastic tubing in any wiring. Heat shrink has been called the duct tape of electronics and comes in handy in a wide variety of applications. Now then after there is a soldering iron which is very commonly used in circuit making. When it comes to create permanent circuit, you will need to solder the parts together. So when you are ready with testing your prototype and now it's time to build your circuit permanent, then you will use the soldering iron to permanently join your different parts or means your LEDs or resistors or different types of capacitor. You will join everything on PCB with using the soldering iron. To do this, a soldering iron is tool you would use. Of course, soldering iron isn't any good unless you have solder to go with. You can choose leaded or lead free solder iron in few diameters. So there are two different types of soldering irons are available in market. One is fixed voltage soldering iron, means it has no variation option, and the another is variable soldering iron. In this variable soldering iron, you can vary the temperature of the lead. Means according to your purpose, according to your necessity, you can vary the temperature of it, and you can change it from lower to maximum as per your requirement. In this soldering iron, there is also a stand which is used to keep your lead into it while not working with it. And there is also a copper wire which is used to solder. Now, our third subtopic is active and passive devices. So let's see what are the active and passive devices. So first is passive devices. Here we will identify the passive devices used in electric circuits. So as I mentioned earlier, passive devices are ones who doesn't need a external or individual power source to run. They can operate without them. So the very first component is switches. So switches can come in many forms such as push buttons, rockers, and momentary and other. Their basic function is to interrupt circuit current by turning circuit on and off. Means the switches you are seeing in images are nothing but you are operating them manually. Your physical parts are moving, and according to on or off operation, they will interrupt circuit, they will close the circuit, or either they will close the circuit or open the circuit, and they will perform electrical operation then after. Our second component is resistors. So resistors are nothing but to resist the flow of current in the circuit. So resistors are known as you can say a bump in a road, which is bumps are used in on a road to limit the speed of vehicle. Similarly, resistors are used to resist or to limit the flow of current. The amount of resistance that a resistor offers is measured in ohms. Most resistors have colored stripes on the outside. This code will tell you its value. You can use multimeter or any other code to calculate and determine the value of a resistor. So these resistors doesn't require any external or individual power source. Now thereafter, it is a variable resistor. The name itself suggests that the value of resistance you can vary as per your requirement. So a variable resistor is also known as a potentiometer. These components can be found in devices such as a light dimmer or volume control knob for a radio. So when there are uses or applications to increase or decrease value, or to light dim or increase the light, you can use this kind of resistors. When you turn the shaft of a potentiometer, the resistance changes in the circuit, and that change in resistor will perform the task of highering the volume or highering the intensity of output or lowering the intensity of output. Then there are capacitors. So capacitors store electricity and then discharge it back into the circuit when there is a drop in voltage. So a capacitor is like a rechargeable battery and can be charged and then discharged as per your use. The value of these capacitors are measured in farads, nanofarads, picofarads range. Now inductors. So inductors are nothing but a passive electronic component that permanently stores energy in a magnetic field when electric current flows through the inductor's coils. So as you can see in the images, there are coils which are used when current flows through them. They stores temporary energy in a magnetic field. Then light dependent resistors. So the name suggests the value of resistance is dependent on the light. So these are light dependent resistors. So value of resistance changes according to the intensity of light falling onto it. A light dependent resistor is also a variable resistor but controlled by the light. The resistance in the circuit changes with the intensity of light. Light increases, it changes the value of resistance. If light falling onto it decreases, that also changes the value of resistance. These are often found in exterior lights that automatically turn on at dusk and off at dawn. Means in the morning it turns off and evening it turns on. Then the diode. So diode is a device which allows electricity to flow only in one direction and blocks it from flowing in the opposite direction. So these are the primary devices used to route electricity from taking an unwanted path within any circuit. Light emitting diodes. So these are the LEDs which we see in day-to-day life. So these are the diodes, like a standard diode, in fact, that electrical current only flows in one direction. The main difference is an LED will emit light when electricity flows through it. So these are the diode which emits light when the current flows through them. There are two different legs of it, as you can see in the image. There are two legs of this diode. One is anode and the other one is cathode. So how to identify them? The longer one is anode and the shorter one is cathode. Anode is positive terminal while cathode is negative terminal. Relay. A relay is an electrically operated switch. So a relay is nothing more than a switch. It is a switch which is operated electrically, that opens or closes when power is applied to its terminals. Inside a relay is an electromagnet which controls a mechanical switch. Now this was all about passive components. Now let's see the active devices or active components. So first is transistor. What is a transistor? So a transistor is also a tiny switch which are used to turn a current on or off when triggered by an electric signal. So whenever there is a current flow through one terminal of transistor, the other two terminals of transistor controls that output of current by amplifying it or to decreasing it. It can also be used to amplify electronic signals. A transistor is similar to a relay except with no moving parts. So in transistor there are no moving parts, but it performs similar as relay to turn off or turn on current or to amplify any electronic signals. Then after there are integrated circuits. So IC are called as integrated circuits. So an integrated circuit is a circuit that's been reduced in size, means they are reduced in size to fit inside a tiny chip. This circuit contains electronic components like resistors, capacitors, but on much smaller scale. Integrated circuits come in different variations such as 555 timer IC, voltage regulators, microcontrollers, and many more. Each pin on IC is unique in terms of its function. Now moving on to our last subtopic, which is circuit and schematic diagram. So what is circuit diagram and what is schematic diagram? So first of all, we will see what is a circuit. So an electric circuit is a circular path of conductors by which electric current can flow. So this is nothing but a conducting path through which electric current flows. There are two types, closed circuit and open circuit. So a closed circuit is like a circle because it starts and ends at the same point, forming a complete loop. Means a closed circuit is a complete loop. A closed circuit allows electricity to flow from the positive power to the negative, means to the ground, without any interruption. So there is no breakage, a whole loop in which current flows through the first end to the very last end continuously. While in contrast, if there is any break in the flow of electricity, this is known as open circuit. Open circuit means there will be some point when there are no connections or no conducting path, they will be open. So they are called as open circuit. As shown, all the circuits needs to have three basic elements, which are a voltage source, a conducting path, and a load. So in this image, you can see both an open circuit and a closed circuit. So open circuit is when the switch is closed, means the switch is closed. The switch is closed, but the connection to the load is open. So there is no complete path for current to flow through. So this is called as open circuit. In open circuit, the load connected to it remains off. So this is called open circuit. While in closed circuit, the operation of switching on a particular switch closes the contacts with load. So there is a whole conducting path for a current to flow through, and hence the load connected onto it will glow or will be turned on. So whenever there is a closed circuit, the load connected to it will turn on. Now, schematic diagram. So, schematic diagram is nothing but a symbolic representation of a circuit. So, this diagram uses symbols to illustrate what electronic components are used and where they are placed in a circuit. So, a schematic diagram lets you see the components, means which are the components used in circuit and the location of a particular component. These symbols are graphic representation of the actual electronic components. So, in schematic diagram, each component is graphically represented by a perfect representation. These schematics are extremely helpful for beginners when first learning circuits. So, as you can see in this image, this is how your schematic diagram looks like. Here's an example of a schematic that depicts an LED circuit that is controlled by a switch. So going from a clockwise direction, it contains an LED, then after a resistor, a battery, and then a switch. So when switch is closed, the LED will turn off, which will denoted as a closed circuit, and when there is switch is off, means open circuit, the LED will not be glowing or it will remain turned off. So this is how your schematic diagram looks like. Now these are the some symbols of electronic components which you can use in schematic diagrams. So this is how resistors Light dependent resistors, relay, LED are denoted in schematic diagram. Cell, battery, AC source, emitter, voltmeter, galvanometer, resistance, variable resistance, bulb, closed switch key, open switch key, closed plug key, and closed tapping key. This is how you can denote the different electronic component in your schematic representation. So this was all about our second lecture of component identification. Thank you so much.